But the main thing to keep in mind is the categories. That's most likely to use a bar graph. So in the world beyond school, when you go to work, when you maybe measure stuff, you have to know how to present your information, and you don't want to present it incorrectly because someone will say, why are you using a bar graph for something that's not a bar graph? So you have to be very, very clear to use the um, right presentation of that.
All right.
Okay, let's take a look at the next set of data. So the next set of data, it's completely unrelated to the first. These are just when you're teaching, they give you examples here. So they are saying they measured the number of black bears every year starting in 1993. This is a time series data. When you're counting data every year, it's
Is it
considered
like
a time
line
series.
graph?
A line plot, line graph makes the most sense, yes. And that's because of the time.
The time, right?
And you do connect the dots. Okay, so like notice that they're not just there. You would actually want to show, okay, there's 30 to 37 to 46. Oops, I didn't mean for that to connect. But then it drops down, then it goes back up, down, and you kind of see a trend. Like if you were to create some sort of a trend line, you might see that it's always going up, but it's essentially to see what's happening to the data over time. Is it getting bigger? Is it getting smaller?
Okay.
Is that okay? Is that clear?
Yep.
All right.
So I basically need to memorize that second document I sent you, the one with like the
Well,
descriptions of when to use that.
some of them you will never not use in the class, like the pictograph is like something you would use in, I'll just say, third grade or something. Like you're not going to use pictographs in this class.
A
Um,
pictograph?
Pictograph, yeah, the top one. But yeah, everything else is in play.
Okay.
All right, so the next one here, there's two possibilities for this. So they're measuring the raccoon population changes. So
Um,
there are two possibilities here, and they're both correct, but stem and leaf plots, you have to
stem
put
and
all,
leaf plots are for grouped in tens, so I'd probably go with histogram because it's gonna looks more accurate.
well, it depends how much time you have, and it also depends on, there's kind of a threshold where you get tired of doing this, breaking it up into orders. Like if you had to do it by hand, you would rather do a histogram. The computer will do both, but there's a point where the data set is too large. So yeah, you'd probably want to use a histogram for this.
All right.
And there's whole courses and learning how to organize the data the way you see here.
Okay.
Part D here. All right, so we got a year-long study.
A lot of motor deaths.
Yeah, they're big on this. I mean, they could have just picked, I don't know, sports stuff or whatever, but who knows? Um, this is a lot like A, although there's a lot of group.
Yeah.
Okay,
So it'd probably be another bar graph, right? Because
probably, and that leads me to go back to A and say that you could have used a circle graph
but
if you wanted to.
it doesn't really mention percents there.
You can convert them to percents. You also tend to use circle graphs when there's fewer categories. There's almost no way to do this many categories down here in a circle graph. So D is for sure a bar graph. We can say that for sure. But the others, And there's not like a wrong answer. It's not like you can present it completely wrong. It's just that there's better, better choices.
Okay.
These are not test questions, by the way. I mean, these are not even close. Like you would be asked to actually create one. So the next example here, this is good for us to do.
Is this next one like a test question?
Mm, well, maybe they would ask you multiple choice thing. So qualitative versus quantitative. So quantitative are numbers.
Yeah, and qualitative is just data.
It's categories or names, groups.
B and D are qualitative, A and C are quantitative.
All right. So A is, you said A and C are
Are
qualitative.
quantitative, yeah.
Yeah, quantitative. Yeah, and then Jersey numbers are categories. So that you are correct. Okay, good. Um, let's try this as well.
Number 1 is qualitative, 2 is quantitative, 3 is quantitative, 4 is qualitative.
You got it. All right, so we're really moving through this pretty quickly. So here's another, I guess, quick question for you to think about is how would you present this data in a meeting? What type of chart might you use for something like this?
Either a circle graph or a bar graph.
Yep, good. The next one here is, now you're possibly comparing two groups. Although I guess we haven't talked about that either.
I feel like it's not change over time, so it's not a line graph, but it's like a line graph.
It is. I don't think you're I think you're
Would
yeah,
it
okay.
be
Now
stem and leaf?
it is not. I see. I didn't realize they asked you this one. It's box and whisker. Box and whisker. So you can actually do one for each. And so you would see something like, I'll just make it up here. Like the first one might be something like this, and then the second one might be something like this.
Okay.
Like A versus B, and you'd see a
Yeah,
clear
that
trend.
makes sense, yeah.
So when you're comparing two data sets, that's a possible way. It's not the only way.
All right. So it depends on like the amount of data and the type of data and like the way it's presented,
Exactly. Yes.
which just makes
Okay.
it harder for the students.
Yes. Yes. So there's a book out there. There's some TED Talks. I don't know if you ever have to watch those on how to lie with statistics. And they mean it in like a kind and gentle way. They're like, no, you don't want to actually do this, but they're saying there's a lot of ways that you can mislead with numbers. Okay. And so mislead means some of the following, like it does not have a title. Spacing is off. The big one you see is where the scales don't start at 0. I don't know if you're active on social media, but you see kind of stuff like this sometimes out there where they'll really mess up these things.
And it'll start at like 100.
Yeah, they'll say like win totals and they're like 9 and then this is 10 and they want you to think it's like so much higher, but if you look at it in context, it's not.
Yeah.
The graph need a key, like they don't get, basically like they're omitting information. Are the components of the graph the same size? Sometimes they try to make them look thinner or wider or longer or taller. The whole point is to do something deceptive. And there's a lot of ways to do this. So let's look at an example here. Um, and I don't know
So
if you,
that's
I can,
the bar graph.
yep.
So is that it?
Well, it's what's misleading about this. Like right now, it
It
looks like,
starts at 15,000.
yeah,
So
it looks like,
it looks pretty small, and like it makes the cost look smaller when it starts at 15,500.
it also makes you think that it's going up by a lot. But if we were to graph these numbers, they really wouldn't look that different.
Yeah, because of
But it
and
looks
they're
like there's,
basing it in $500. So
yeah, they're really,
scale of
like,
that wouldn't be.
yeah. I mean, you see this like right now with gas prices. They'll show you a graph like this, and they're like, 479, 489, and it's like, well, it's only 10 cents, but it um looks like a lot.
Yep.
All right, here's another one for you to look at. All right, mean hourly wage for employees at a fast food restaurant.
It's misleading because it looks like it's going up in huge amounts, but it's going up by like 3 to 6 cents per increase.
Got it. So you got to be careful here, because people will notice this. If you try to present this and you're in the right audience, they will say, you will look, they have this expression, egg on your face. You will look like the person that doesn't know what they're talking about when you try to push something like this.
Yeah.
All right, so that is actually everything in the lesson there. Um, box and whisker plots, I think we might have talked about. We could do one.
Yeah, no, that
But
was gonna be the next thing I wanted to do was just practice box and whiskers because I they're not very fun to do, and if you screw up once in the data, you're screwed.
yes, yes. All right, so I've got one um from another student I was working with that I think would be good for us to work on here. It's not a big data set, so it's pretty easy to work through. Okay, so one of the first things you have to do here is to put the data
Into numerical order, yeah.
into order, yeah. And so one of the things I do when I do this is I cross out as I go. So
Yep.
0,
And you have
1,
2 1s.
right? 2 2s, 2 3s, 2 4s, and then a 5. The other thing I do is I count how many I have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And
And
then
check it back.
exactly. You always check, 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 check. All right. So there's an even number of numbers. The
Yeah, so that
median,
means it's the average of the fifth and the sixth number. So I usually count 4 in, and then add 5 and 6, and then divide by 2.
good.
You get
Now for,
median is 2.5.
yeah, now for Q1, you split the data in half because there is,
Yep.
and you have to look at this grouping on the left and this grouping on the right to find Q1 and Q3.
Yep. So then Q3 is 4,
Okay.
and Q1 is 1.
And then you also find the min and the max, yet another reason to
0 and 5.
put it in order here, right?
And
Okay. Now, in terms of graphing this, you start at the median. So I'm going to go right kind of in between there. That's 2.5. You either go right or left for Q3. And then, or I'm sorry, you either do Q3 or Q1 first. It doesn't matter which order. This one's got a lot of symmetry in it. And then your whiskers, I don't know if you have cats, but your whiskers go out to the min and
Yeah,
the
min and the
max.
max.
There are some exceptions to this, which occurs when you have outliers, which I don't know if you guys are talking about. Now, there's a few other things we can calculate here. So I'm going to grab this list.
The IQ, or not the,
Yes,
yeah, the
yes,
IQR.
IQR. What is the
How would you,
IQR?
is it like,
It's Q3 minus Q1.
that's it?
That's it.
Oh.
It's a 4
Oh,
minus
then what's
1.
the hard one? The
Well, there's
range
the,
is easy. The
these are the
hard one is like the mean minus, or like the numbers minus the mean.
that's
Mean
standard.
absolute deviation.
Yeah, are you guys doing MAD?
Yeah,
Okay.
I
Yeah, so
hate
MAD,
that.
yeah, mean absolute deviation. You have to take, well, first of all, you have to find the average. So I'll let you,
Find the
let me go.
mean.
Yeah, can you find the average of these numbers for us?
Yes. Let me pull up the Desmos website.
Yeah, and if you're allowed to use technology, please do.
Yeah, that's graphic. Desmo.com. Not graphing. Math tools. Scientific calculator. So then 1 plus 1 plus 2 plus 2 plus 3 plus 3 plus 4 plus 4 plus 5 is 5 by 10. So it's 2.5. The average is 2.5.
Very good. Very good. So let's not overthink what the mean absolute deviation is. You take each number in your data set and you subtract the average, but you take the absolute value. So it's always positive.
Yep. Well, you don't have to, but you're going to square it, so it will always be positive.
That is if you're doing standard deviation.
Oh, that's
The
what we're doing. Yeah,
well,
standard
well,
deviation.
well, MAD is different. So you got to be careful. There's a lot of measures of
Yeah, no,
this.
we're squaring it. We're doing standard deviation. Yes.
Okay. I should give you a different data set if we're going to do standard deviation. So let me do that real quick here. So we should do this again. Let's say the data set 4, 7, 8, and let's go. I don't know, 9.
Okay.
So first find the mean.
Yeah, that's what, yeah, that's the symbol. So 4. 28. So the mean is 7.
Okay. So now that you can make a table, the
Yeah, that's
first
what I always
column.
do. 4, 7, 8, 9. And then you have 7 all the way down. And then it'd be -3, 0, 1, 2. Then that squared is 9, 0, 1, 4. And then it's like it's that minus
So
the
it's
mean.
this it's the summation of that last column.
It's
So you
x
have to add that.
squared minus the mean. Yeah. And then
So you add the
so
numbers
then
up,
you get
and then
14 divided by
they
4.
should. Yeah. So just double check here. Some instructor, there is, this isn't quite correct in real terms, but some instructors use n-1, so please double check that.
Yeah,
But
no.
but this is actually the variance. And then to get the standard deviation, you have to take the square root of that number.
Yeah.
And for me, you can just leave it as square root of 7 over, well, sorry, square root of 7 over 2, a lot of time, or sorry, square root of 14 over 2. You can go to the calculator if you're allowed.
Yep. 2.64.
Yes. So the only real challenge is just being patient with it, putting the numbers in, squaring them, and then adding
Just
them up.
making sure the data's right.
Yes. Okay. Anything else that you're remembering from this part of the course that you need help with?
From this part, no, let's see what we've done this. Like,
Do you have
I don't
anything,
think we
any
got
idea what
us.
you guys did today? For
I don't, yeah, we already went through that. Oh, what
okay.
we did today? No,
Yes.
I have no idea what we did today. She didn't post
Okay.
it.
Nothing posted.
Yeah.
I mean, I'm happy to do more final exam prep with you. Do you
Yeah.
know what's going to be covered on it that we haven't covered, or if you want me to pick a topic?
Well, that's factoring, then they're solving nonlinear systems. Trying
Let's
to
do
remember
that.
what, yeah. Trying to
We
remember
have,
what solving nonlinear systems is.
it's kind of, it's not as bad as you think. Let's look at one here. Why do they want you to graph that? Okay.
Oh, isn't it like substitution, elimination, and all that stuff?
Kind of. I mean, you generally use substitution,
Yeah, that's
generally.
my favorite.
So the nonlinear part just means that they're not both lines.
Yeah, so it'd be negative 2x plus 3 equals x squared plus x minus
Yeah.
1.
Now, the reason instructors like these so much is you have to then use your knowledge of solving quadratics. So in this case, I recommend moving the
Yeah,
2x over,
because you
the
got to
minus
keep the
3.
x squared positive.
Yes.
That's x squared plus 3x minus 4. And that's perfect squared trinomial, right? Or is it not because it's a
It is,
negative 4?
it is not, it is not. It's just a straight factoring.
So would it be x minus 2x plus 2?
Try again. Two numbers that multiply to -4, but add to +3.
Oh, x plus 4, x minus 1.
X plus 4.
Yep,
Yeah,
x
X
minus.
minus 1. Okay, you're setting that equal to 0. What are your two X values?
1 and negative 4.
So that's only part of your answer. That's just the X value. You got to get the Y value by doing the other one.
So then plug it in. So then x has two answers.
Yep, you have to say when X is -4, what's Y? And when X is 1, what is Y?
Okay, so 1 is negative 2. So 1, y is 1. And when it's
Yes,
negative 4, it's 8 plus 3 is 11.
you got it. Now, I'm going to just go through this graphically. So a quadratic and a line can hit twice. It can hit once
Or 0
or
times.
or it can hit 0 times. So keep that in mind when you work through the next problem here. You can
Just
use,
look really quickly to see like what we did this
sure,
semester, like all of this semester. Quarter grade. We've done chapter 9, which is quadratics. And chapters, we've done chapter 9, chapter 11, chapter 8, and chapter 7, chapter 8, chapter 9, chapter 11. And volume Pythagorean theorem. A bunch of factoring, really.
you spend a lot of times factoring.
Yeah. The next problem.
So here's what I'd like you to try.
8. So
Yeah,
then, so it's x. So it's x plus 6. Y equals x plus 6.
try
X
again.
squared plus 6.
Okay.
Uh, that I don't know if that's factorable. Oh wait, we don't have a middle term.
So I mean, here's what I heard. 0 equals x squared plus 6. Is that right? I think you might have said y, but the y is eliminated when you
Yeah,
substitute.
yeah, that's what I got.
Okay.
Oh,
The
minus 6 square root.
that's
There's no solution
no solution because there's no way to solve the problem.
unless it's an imaginary. Would it be I? The square root of
Yeah, I
I?
mean, not in the real domain. We're in the real
Yeah,
domain.
no real solution. Yeah.
Yes. Just usually is enough here. Now we did talk about the idea of using elimination with these. Or I guess we should cover that quickly because you may see a problem like that
Yeah, you'd probably
on.
multiply the second equation by -1, or this one
Yeah, so
by the top one
I
by
just
2.
I like to just subtract. Remember, you only have to eliminate one of the variables. Usually you're eliminating y,
Oh
typically.
yeah. So
So this
then
becomes 0 equals,
-2x squared.
okay,
Uh,
plus x minus
minus
2x
x
minus 3 minus
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 5.
2.
Or -1, yeah.
Yes. So
So then
this is a
factor
different
out
type of factor.
-2.
You cannot factor out a -2 because it doesn't go into these. If you do that, you're going to end up having to complete the square. This is that type of factoring that's grouping. You have to take -2 and multiply by
Yeah, but so then
-1.
it'd be 2. So it'd be, oh, you'd have -2. So x minus 2x plus 1.
Well, think about what you just said here, because sometimes this doesn't work, and then we have to go. This becomes 2. So you have to find two numbers that multiply to 2, but add to -1.
Yeah.
Is that possible?
Oh. So -2 and 1?
They have
No,
to multiply to 2. So it's either 1 and 2 or -1 and -2.
that doesn't work. Neither of those work.
So you can't factor it. What's your backup plan if you can't factor?
Probably try to decide if quadratic formula or complete the square would be easiest here.
Generally, when this is odd, you don't use completing the square. I'd like to see you do quadratic formula on this. So a equals -2,
Yep.
b equals -1, c equals -1.
Okay, so it's -b plus minus square root of b squared minus 4ac over 2a.
Yeah, do the part under the square root first, the discriminant, because that'll tell you whether it actually has a real solution or not. It
And
may not.
1 minus 4. It doesn't. Wait, 1 minus 4 times. No, it doesn't.
You got to be really, really sure, right? Like, because there's
Yeah, because that's
no
because
going back.
that'd be
So
1 minus, that'd be 1 plus 8, right? Because -4 times -2.
is 8, but then you times -1 is -8.
Yeah, it'd be so, and then that gives you negative. So it
-7.
could
Yes,
be a real solution.
no real solution. All right, but just to get back on that, I think we should do a couple of those grouping problems. That's what I was trying to get out of that one. It didn't work out, fortunately. So let me give you one of those grouping problems. Okay, something like this. 2x squared plus 7x minus 15.
So
So
then,
this is that one where you
so
combine the
negative
first and the
30,
less.
but adds to 7.
Yeah.
3 and minus 10 and minus 3. So x minus 10, or x
So
plus 10, x minus 3.
yeah, so this is as far as I'm gonna go for writing down what to do here. You can please finish
Yeah,
this
so then
one
you get
off from here.
2x, so then that'd be x plus 5. So then you need to have x plus 5 is one of the things, and then b minus 3. 2x minus 3x plus 5, so then x equals negative 5, and x equals 3 halves.
Okay. What is I'm sorry, what were your factors? I didn't
Oh,
quite get that.
2x minus 3 and x plus 5.
Like this,
Yep.
that does work. And then you just set it x equals 3 halves minus
Yep.
5. All right, good job on that. Yeah, what else? Do you want me just to pick problems, or do do you have any other areas you want us to work on?
I'm thinking I might go back, like all the way back to like just the earliest stuff we worked on in quarter 3, which
Okay,
was
what would that
chapter
be?
set. That's factoring, that's graphing, quadratics. I mean, by doing this, we're kind of doing most of the stuff we did this year.
Yeah, I mean, I'm happy to just find more problems. It would be all
Yeah,
over the
probably just
place.
find more problems because we're doing like most of the math that we've done this year.
Okay,
Can you find like a word problem maybe?
sure. Those are going to be mostly quadratics.
Yep. Well, most of what we did this year is quadratics anyways.
Yeah, you guys are really hitting that pretty hard here.
In geometry, do they use a lot of quadratics?
It depends on if you're taking the honors geometry, they tend to then really um, emphasize it a lot, but depends on the teacher. All right, let's look at this here. So Jason jumped off a cliff into the ocean in Acapulco while vacationing with some friends. His height as a function of time could be modeled by the function h of t equals minus 16t squared plus 16t plus 480, where t is the time in seconds. How long did it take for Jason to reach his maximum height? So he
Negative
jumps.
t over 2a.
Yes. So go ahead and calculate that for us, please.
1/2 second. 1/2 of a second.
Yes. So t, not the scale here, 1/2. The next question is going to ask you, what is the maximum height?
So then you plug in 1/2. So you 1/2 squared is 1/4. Let me go to my calculator. And then 0.25 times where's the negative? It's gonna go times negative 16 plus 16 times 0.25 and then plus 480. So 480 feet.
Uh, well, I mean, you start by
Oh
saying
wait, no, no,
it,
no, no, no. It's
it is
point
was 1/4
point
plus.
5. So 484 feet.
Yes. So it doesn't get up that much higher. He could have just fallen straight down. Um,
That's a
last question.
long fall.
Well, people are thrill seeking. All right. The last question is to figure out when it hits the ground. So you have to set the whole thing
Equal to 0.
equals 0. Now this one you can do by hand. You have to factor out the
Negative
GCF.
16. And that's t squared minus t and then minus 30. equals 0. Probably no 6 and 5. So it'd be t minus 6 t plus 5.
Okay, you got to set them equal to 0.
Yeah. So then you'd get 6 would be your only logical answer because -5 wouldn't work.
Yes. Now keep in mind, most of these questions are not created to be realistic. I mean, that's a long time to be in free fall.
Yeah, I mean he is 480 feet in the air.
That's true. That is true. Not something I want to do. That's for sure.
That sounds like so much fun.
Yeah. All right. Here's another one. This is the another style of problem you'll see. This is the farmer. Let's see if you can set up a picture for this.
Oh yeah. So it's like a width of x feet and length is 8 feet less than his width. So x minus 8 to the width. You just have to draw this one. So
Yep.
the width is x and the length is x minus 8.
The dimensions go either way. It doesn't really matter.
And then so x measures 240. So x squared minus, so you have to FOIL that. So x squared minus 8x
Equals
equals
240.
240. Yeah.
Okay.
And then you take out x out of one side. So
Nope.
you get,
Nope. You gotta move the constant over.
oh, okay. So then x squared minus 8x minus 240 equals 0.
Okay. So you're gonna have to factor that. You can use the calculator to figure out the numbers.
Okay. And 240 divided by 15. No, they're 8 apart. So then 240 divided by, let's go, that's not, it's lower than 10. We 8? No. Twelve and 20. So it'd be x minus 20, x plus 12. And you have to set those equal to 0. And x equals 20 and x equals -12. But 20 is the only one that would work.
So let's
So
just
x
say,
equals 20.
yeah, let's just say that that's right. And it is, but keep in mind, sometimes it doesn't ask you just to find x. It might ask you to actually find the length and the width. So
Yeah.
be aware that that could be another
Yeah. And then the
variation
length
on this
would be
problem.
20, or the length would be 12 and the width would be 20.
Yes. All right. So here's another one to think about. Picture would probably help on this one.
Area of a triangle. There's a specific formula for area of a triangle, I'm pretty sure.
Area of a triangle is 1/2 base times height, or base times height divided by 2.
So b times h divided by 2.
Yes. The altitude is this vertical. I don't know if that helps.
Yep, is 5 less than its base.
So the base is all the way across.
Yeah, so the base is
Oh,
b minus 5. Or no, the base is b.
okay.
And the altitude or height is b minus 5. So you get b squared minus 5b over 2.
Equals 42.
Yep.
So how do you undo this division by 2?
multiply it by 2 and then move it over. So you'd get b squared minus 5b equal or minus 84 equals 0.
Okay, go ahead and try solving that, please.
Okay. 5 apart. 12 and 7.
Okay, that's
So
correct.
then it has to be negative. So then x minus 12, x plus 7. So then x would have to equal 12 because it can't be
Okay.
negative, but then you have to plug
So,
that back in. So the base
yeah,
is 12 and the altitude is 7.
that's right. And just be careful to not
Oh yeah,
omit
inches. Yeah.
units because there's a small chance that you'll get dinged. Okay, good job on that. We're gonna go ahead and stop here for today.